Hi, folks. Thanks to be here for this talk about a gentle introduction to stream processing. I'm Nicolas Frankel. I've been a developer for like 20 years this year, and now I'm a developer advocate. I work for a company called Hazelcast. Hazelcast has two products. The first one is an in-memory data grid. And if you've never heard the term in-memory data grid, you can think about distributed data structures. So instead of being constrained by a single runtime, such as a JVM, you can shard or replicate your data structures across nodes of a cluster. And the second one is Hazelcast Jet, and it does in-memory stream processing. And since I will be describing it a bit because I will use it in the demo, I won't talk about it any further. However, this talk is not about Hazelcast. So, I mean, most of the talk is completely agnostic, and you should benefit from it. Also, this is an introduction, so if you're already expert in stream processing, I'm not sure you will get anything out of this talk. If you are wondering what it is, then you are in the right place. So the schedule for today will be, so why streaming? What is streaming? Why are we streaming right now? I mean, we have been using batches for ages and they always worked. Why do we do streaming? The second point that I would like to address is defining like streaming versus storage of events. Those are two separate concerns. Then I will need to describe a bit Hazelcast Jet, how we do streaming at Hazelcasts. Then because of the demo, I will use an open data endpoint, and I need to tell you about some bits and pieces that you might find interesting regarding the fact that when you use data, there are some couple of issues that you don't think about, but they will probably like bite you at some point, and it will be about open data, but basically probably the data you will be leveraging inside your company will probably have the same issues. And then finally, I will try to show you a nice demo. Again, if you've got any question during this talk, I will do my best to keep an eye on the QA tab. So please write that down. I want this talk to be as interactive as possible regarding the circumstances. So feel free just to ask. And again, I will do my best to answer as fast as possible. So as I said, I was a developer and I've been in IT for 20 years this year. And when I started my career, all the data was stored in SQL databases. You had no choice. You wanted to store data, SQL database, whether that was relevant or not. And actually, in some cases, it was not really relevant. And mainly, there were two use cases where SQL was not really super nice fit. For example, analytics. So imagine you are a supermarket director. You want to know your sales in the previous hour. For example, you have a stock of bananas. It's Saturday, you won't work on Sunday. I mean, it's France, so nobody works on Sundays in France, or not many people. And you know that they are very mature, so if you leave them one more day, well, you will need to throw away your stock and by Monday. So the idea is you want the sales of the banana hour by hour, and to check if you will sell your whole stock, and if you don't think you will sell it, you will make promos so that you sell more bananas, and then you can sell everything and not waste some of your stock. The other use case where SQL is not a really great fit is reporting. There are two main reports. In general, there is a report when you access your mobile app and you want to check the balance of your accounts. Or you might, depending on your country, there might be regulation when you've got yearly or monthly reporting of your balance and your operations. And in that case, SQL might not be great fits. So why is that? Because those are two conflicting use cases. When you use an application, normal application, probably you will be using transactions, especially with banking. You will want to make sure that when you send money, well, the money from your account is removed. So, well, there is on one side, you will like add money to another account. On the other side, you will remove money from your account. When you get to the reporting side, you don't care about that. What you care is having very, very fast reads. Like you don't want to, for example, let's imagine you are doing event sourcing. So you store the data as like a series of events. You don't want to play all the events to get the balance. You want to get the balance like right off the bat. So the idea is on one side, you want data that is normalized. You want to have transactions. You have to have constraints when you have like the regular usage. And on the other end, you don't care how the data is stored. What you care is to be very, very fast. So on one side, you want correctness. On the other side, you want speed. Those are two conflicting requirements regarding SQL. SQL actually implies normal forms, so data deduplication. Then when you want to have data from different tables, you will have joins, and the more joins you have, the slower it will be. And it implies constraints that when you write data, it must conform to a certain shape so that you know that the data you are storing, then it's like, I don't know, an int or a long or a big int or whatever, or a date. You don't want to have a string in the date field because when you read it, there will be some issues. And for this reason, since I started working, at least there was a need from like this process called ETL, extract, transform, load. Why? Because we have different actors with different requirements, and using the same database doesn't, I mean, it's worthless. And it might be even worse because if on one side you've got your regular app doing transactions and writing, and on the other end, you've got data analysts that needs to join across 10, 20, 30 tables, then you would probably hit a performance bottleneck at some point. So even at that time, there was this idea that, okay, we will have SQL databases, but on one end, we will have a regular SQL database with constraint joins, whatever. But then there will be something to extract data, to transform it, and to load it into another SQL database, but without any constraint. Probably data will be denormalized. We don't care about duplication because we just want to read fast. And that's the batch model. That's what we have been doing for ages. Batches are everywhere. I believe that even if you are a junior developer nowadays, you have been exposed to batches in some way or another. And batches have two interesting properties. The first thing is they are scheduled. They are scheduled at regular intervals. It can be like yearly for the banking account. It can be hourly. It can be anything. And they take some time to run. And you know where I'm going to. At the beginning, when you develop the batch, you make sure that if you need to run every X, then your batch needs to run less than X. But with the amount of data growing and growing and growing, in general, you start with X minus something, and the delta is getting smaller every day, week, month, whatever. And at some point, the execution time overlaps the next execution schedule. It's not great when it happens. Also, if the batch fails during execution, you need to restart it manually, which means that even if you got a comfortable margin, like, hey, I want to run under X and I take Y as a margin, Well, if it starts, if it fails mid-execution, there might be some overlapping nonetheless. And what happens when you load everything into memory from the database, but your memory is not big enough to handle everything? So for this particular problem, you will probably need to do some chunking. So instead of loading everything from the database, everything from disk and in memory, you will need to like chunk your database into like small portions and handle each chunk at a time. But then you will need to think, oh, but what about if new data comes in when I'm processing? That doesn't work that well. There are no transactions anymore. And for this reason, we saw the rise of big data, because SQL databases, they were designed at a time where we had enough power, the data was small, and so the idea was if we needed more power, we scaled like vertically. We added more CPUs, we added more memory, and it worked more or less. But now it's not possible anymore because the data is growing exponentially and vertical scaling has a limit in any operating system. And the design of SQL database was never meant to scale horizontally. So the rise of NoSQL databases happened just because of that. They actually are designed around horizontal scaling. You need more power, well, you just add more nodes. And then you can parallelize stuff, especially if you are doing MapReduce. Also, there is something interesting that a lot of those NoSQL databases, they say, hey, you don't need no schema. Well, that's not completely wrong, but not completely wrong either. Like in general, if you don't use a schema when you write, meaning that it can be free-form data that you put into your data store, you will need to read this data and somehow infer the format by yourself. So that's the infamous schema on write, where like SQL is very strict and say, hey, this should contain only a date. Then you cannot just put a string inside of it. And if you have a data store that allows everything, well, when your application reads the data, it needs to say, what like type is it? Is it a date, or does it look like a date? Can I transform it to a date, or it's not usable at all? So you might be very, very fast on read, like from a physical point of view, but somehow you will need to make some choices regarding, hey, like what about the data that I cannot read because I don't know which form it is in? And now we are at a time, or it was already a couple of years before that, we are using events. Like you might have heard the term event-driven architecture, but it's even before that. When you are using a computer, using a graphical user interface, you are actually like using event-driven programming. So every time you click on something, every time you push a button, there is an event and you can react upon it. And like event-driven architectures are just the idea to leverage that way of designing the world. That could solve all our problems in one go. Like remember batches that take everything into one big like piece, and they need to load it in memory, and now you need to chunk it because it might be, no. Make everything event-based, and actually it solves all problems. Of course, there will be other problems afterwards, but I mean, it solves the problems we have at hand right now. The first thing is regarding chunking, because not everything fits into memory. Well, if you process one event at a time, the memory you need to use is very, very small. And because the event is actually also small, it can be easily processed. There is also one side effect that is very beneficial, is that instead of being like pulling the data like at a regular frequency, every hour, every week, whatever, then the data is pushed toward us. Meaning that if we have data and we need to replicate it somewhere, the replicated data is actually very close to the source of truth, meaning we can have like near real time, because there is no such thing as real time. Even light takes time to travel from one place to another. So if you hear real time, it doesn't exist, but let's say close to real time, near real time. And one of the issue is before we were always reasoning in infinite datasets. So we take the stuff from the database and it has like perhaps 10 million of records, but it's a finite number of records. And now we say, oh, we are taking data from the database and we take it as it comes, and it might never end. We know when we start like getting data, but it might never end. Something that you'll probably need at some point is to have stateful streams. In general, we are happy not to get only the data, but to have aggregation of the data, such as the sum. And for example, I mentioned last time the analytics of the banana cells. What is interesting is what happens. So I don't want to have the cell, every cell. What I want is to have the sum of all the cells of the banana stalk, so far. So I probably need to aggregate it. And when I get a single event, I only have this event. I don't have more. So you probably need to somehow store the state at some point, or to define how to store the state so that you can aggregate the data. And this is, you also need windowing to say, hey, for example, I need the cells in the last hour, I need the cells in the last 5 minutes or whatever. So the aggregation is only done in a certain time frame. And for that, you need to define windows. I just don't want to go too deep into detail. There will be like other resources that might be much deeper. Just think that windows, there can be like multiple ways to define windows. The first one would be what is called like tumbling windows. So you define a window of 1 hour and then you tumble it, so it's like every hour. Or you can like define sliding windows. You still define a window of 1 hour, but then you move it like every 5 minutes. That's enough for stateful stream. Just think that if you have a in-memory stream processing engine, you just need to check if it provides states at some point. But from a very, very like high point of view, you can say that streaming is just smart ETL. You can still read from like any source that is possible and write to any target. Just that instead of like being scheduled, you do that in close to real time. And you can like enrich from some other places. You can filter, you can transform, and well, all the stuff that you could do before, you can still do it. And regarding the use cases that I mentioned before, it opens a lot of new possibilities. As I mentioned, now you are close to real time. Like previously, I mentioned that, hey, like I want to have the cells every hour of my bananas, but I mean, it doesn't make any sense that I need to wait a full hour, because actually, if only 50 minutes have passed, I probably already have enough data to make a decision. The last 10 minutes won't change a lot. And what happens if I tell, like if I'm in the batch model and I say every hour, the batch takes time to run. So I won't even have the data when I really, really need it. Now, if I got stream, I have a cell, I've got a new data point on my graph, I can really see the trend in close to real time and I can make informed decisions. Likewise, if you've got this kind of in-memory stream processing model in place and you've got some machine learning model already pre-trained, then you can already like take some decisions without any human decisions. You know that, hey, if I already saw this pattern, then probably it means something, and the automated system can make a decision. Also, I don't know if you are old enough to have heard the term complex event processing. It was very hype when like 10, 12, 15 years ago. It was in the enterprise service bus. So those all those big companies, they wanted to have one single bus where they could publish events, and some other application would just like subscribe. And hey, given that we receive 2 of those events plus one other event in a sequence, it means something. Well, enterprise service bus, to be honest, I never saw any company really doing it like seriously. There were a lot of books for sure, but it was not that like implemented. Now you can still do complex event processing, but now instead of being in an enterprise service bus, it can be in any pipeline you might want. And now imagine we have this pipeline of events, and the question is, okay, but how do we store them? Sometimes we need to store them. Sometimes we just need to process them as soon as they come. Sometimes we need to store them and process them later. And then we need an event storage system to serve as a broker. The most popular one right now is Kafka. Everybody is using Kafka, sometimes for not the right reason, sometimes for the right reason. I also need to mention Pulsar, which is like very close, but has some additional properties. So if you're interested in that, just look at it a bit. Just in a few words, Apache Kafka, it's distributed. There is on-disk storage, which, as I mentioned, can be a good idea, meaning you have a broker in between, meaning that you won't lose any event. Now, if you need to process the event, first you need to write on disk, then you need to like read from this. So sometimes when you want just like very, very fast stuff, might not be that good. So always think that, hey, it's a nice technology. Does it apply to your use case? Perhaps yes, perhaps no. You need to think about it, please. And now we need to do some stream processing. In general, you've got, the ecosystem has a lot of different implementations. And though I work for Hazelcast, I need to talk about some of them. So for example, you've got Apache Flink, which is quite popular. You might have cloud-based one, so just as Kinesis or Dataflow. And I also wanted to give a special mention to Apache Beam. Apache Beam is an abstraction over the implementation, so it allows you to not care about the real engine that you have behind. So you could potentially migrate and keep your application code the same. Of course, it's never as easy as that. The problem is that there is no real specifications or no specifications at all regarding stream processing engines. And basically, it's a leaky abstraction. But still, it's still a good idea. It's also polyglot, so it might be interesting if you want to check. Just a mention of Hazelcast Jet. It's an open source project, so you can use it. Everything that I will show you is completely open source and free. Of course, we have an enterprise offering, but the demo is not about that. Most, if not all, stream processing engine defines a pipeline job. They might use different terms, but in the end, it will be the same. Here, I'm using the Jet semantics. So you first declare the pipeline. It's declarative. It can be in depending on the implementation that you're using, it might be just YAML. It might be sometimes a programming language. But the idea is you declare where you will be reading from, what steps, such as transform, filtering, or whatever, and then where you will be writing to. And then you have a client and you take this configuration or this declarative code and you send it to the stream processing engine cluster. And then it receives it, and it's this cluster which is tasked to distribute it over all the nodes in the cluster because it knows about the topology. Jet offers 2 deployment modes. The first one, if you are a Java developer, is the easiest to start with. It's really great. You just add Jet as a library, and then you start a node by using jet.NewJet instance. So discovery, all the nodes will find each other, they will form a cluster. It's very easy to start. However, if you start being serious, it's not as great because, of course, the application and Jet nodes will compete with for memory on the same JVM. So that's probably not what you want to do in production. In production, what you probably want to do is you want to deploy in a client-server topology. So you have all your Jet nodes, and each node is a single JVM, and it runs only Jet. And then you've got like your application that is a client of the Jet cluster. And as an additional benefit, you don't need to use Java anymore. You can use Python, you can use Go, you can use C#, you can use Node.js, and you can use C++. So we have different client bindings, so you don't need to know Java to use Jet. And this is just the implementation that I've shown you before. Here, you already have like sources that are predefined, or you can create your own custom connector. And the same is for targets. And the rest is just the implementation that I've shown you in the previous diagram. Something that I'm using in my demo is enrichment. So the idea is that in general, your event flows from the source to the target, but it's self-contained. So perhaps it references by some ID some other piece of data that you need to do. And perhaps this piece of data is in the database. And you don't want in your workflow to every time go access the database and get from data, because again, you want to be very, very fast. And so going to the database every time, it's not going to cut it. So the idea is, in general, what you do is you preload your whole reference tables or whatever you need to read data from in memory already. And so if you are using Jet and IMDG together, and Hazelcast Jet embeds an IMDG by default, you can preload it and read from memory, or at least from the network, but without any disk read, which is like very, very good if you are searching for speed. So now I've defined all the processing stuff. Now I want to have some data. And the problem is I want to show a demo where I get free data. So in that case, for this demo, I'm leveraging the power of open data, and open data is to data, what open source is to software. So basically it's data that you can use freely and without any requirements. Depending on where you are living, there might be some open data initiative. So I live in France. There is one open data initiative in France. And of course, it's about the administration that needs to deliver such and such piece of data in such and such format. In Switzerland, there is also an initiative. In the European Union, there is an initiative. Again, depending, I know that in California, so not in the US, but in one state in the US, there is also such an initiative. You need to check what data are available to you where you live. But it's not a free lunch. There are some challenges along the way. So I will go through some of them just to make you understand what problems you could encounter. And the problem is that, well, the lesson here is that even if it's not open data, even if it's data that is inside your company, there you might encounter the same issues. So the first thing, if I tell you open data or data, you think, because you're a developer, I'm a developer, hey, we have a web service. Well, sometimes no, sometimes it's just downloading a file. So when you access a web service, you can have open, like streaming. If you need to download the file every time, that doesn't feel that good for like and close to real time. Then it's just batching and it's not as great. The second problem is if I tell you open data, you think, hey, it's an open format, it's really cool. Yes and no, because you will find that a lot of public administrations, they love Microsoft. They are all using Microsoft Office, and they provide you with data in XLS file format. And sometimes it's not even the new open format, which basically is just a zip archive, and we open specification. So inside you have XML. It's the old one, the binary, completely proprietary format. It happens rarely, but it happens. In that case, good luck. Then I love XML for whatever reason, because the reason is that actually it has a schema. It defines that is actually valid to a grammar and not just like properly formatted. And sometimes you just want to have the grammar. So it was just as I mentioned before, the fact that, hey, schema on read versus schema on write. When I want to read the data, I want to know what to expect beforehand. If I have a schema, that's really, really cool. And now I know that JSON has also some specifications regarding formats, but they are not as detailed as XML, and XML has been here for a long time. But anyway, I want to have a standard. Most of the time, I don't have a standard, and there is always these funny situations where there are competing standards, and then there will one standard to rule them all, but then you've got one more standard because it didn't rule them all. And finally, you might have heard data scientists telling that, yeah, they should be doing data science, but 80% of their time is about curating data because data is not in the right format. Hey, guess what? This is from the data files that I have, and this is supposed to be a time. So I know what 1620 is as a time. I have actually no clue what 2453 is. So should I discard the data point? Should I say, oh, it's like I just removed 24 hours, so it's close to 1 hour on the same day, or should I roll it to the other day? That's just like more inference that I need to do because I have no clue how to handle it. My demo will be about public transportation because I found a nice data point, a data provider. And this is there is a specification for that actually called GTFS. It's not a public specification in the sense that it's provided by Google, but it seems that like some organizations around the world are using it. So before I used a Swiss one, and now I will be showing a Californian one. So it seems to be quite widespread. There are actually two kinds of data. The first one is what they call static data, and that is data that is not supposed to change like seconds or minute by minute. For example, a bus station. Bus station might change, but not every day. And then there is this dynamic data, and hey, it's the position of the public transportation, for example. So I won't go through all of it, but basically there are some files that are required. For example, the providers, the location of the stops, the routes, so from which stop do you go, and so on and so forth. This is the static model. Those are provided as files that you need to load beforehand. And then there is this dynamic model, and I did the model by myself, and it's not meant to be readable on your screen. It's just to show you that it's a bit complex. But basically, the idea is that you receive this feed message. So this is the big envelope. It has a header, so you can get some metadata. And then you've got feed entities. And with each feed entity, you can have an associated vehicle position. And once you've got the vehicle position, well, you can track actually the vehicle. So as I mentioned, I will be using a California data provider. Before I used a Swiss one. They switched their format. I couldn't use it anymore. So now I found this one. I think it's pretty easy. You just need to register. Then you get a token, and then you get access to the data. And the data pipeline that I've coded looks like this. So I read from the web service. I get the full envelope. Now I split, as in the model, the whole envelope into a multiple trip updates. I transform it to JSON. Then I filter out mail from data because otherwise my pipeline breaks, and I don't want that. Then I enrich it with stop times, trips, whatever. And this is what I mentioned before. Here in the payload, I get ID referencing stuff that is actually stored in the data file. So I first load everything into memory, and then I can enrich the data in memory. Then because my front-end developer asked me to, I transform the hours into timestamp. Then I flatten the JSON. Again, it's to more easily handle the JSON on the front end. Then just for debug purpose, I pick some samples. So I put them in the log just to make sure that everything works. Then I transform it into a map entry and I store it into a map in IDG. And this looks like this. This is the architectural overview. So what I've shown you is here, the loads dynamic data. But first, what I do is I start the Jet cluster. Then I load from the files. So I read the file, I transform them to JSON, and I put them, each of the file, in its own dedicated map. Then, as I mentioned, I will actually send the job. The job will actually every time read the REST endpoint, and I will enrich it with what is already in IDG and put everything into a dedicated map. Then I have a Spring Boot application, and the Spring Boot application registers, subscribe to changes in this map of events. So every time there is a change, it will get informed about it, and it will push it into a WebSocket queue. And on the front end, I have another subscription. So every time there is a change in the queue, I will know about it, and I will be able to handle it. So now I have a couple of minutes, and I will try to show you how it looks like. And please, I hope that the codes of the demo are here with me. Here, I have a simple Jet cluster made of a single node. It's not, I could have multiple nodes. It's just a simple demo. So now I have started Jet. Second stuff is I need, as I mentioned, to preload the data, the static data from the files. So if I will have the reference of a GitHub repository here, everything that happens is here in this load static module. I hope the README is good enough and you will be able to read it. And we can see that here. So in the, what did I do? I hope I didn't do something bad. Yes, here we can see that we received some data. So here I'm also picking to see that in the logs something happened. So now the job is finished normally, and it should tell me, yes, job is finished. Oh, it's super slow. Yes, and now presentation. Thanks, Pavel. But then on my, you need to refresh. It happened. I think it already happened last time. Myself, I see myself. So on my own screen, I'm seeing my IDE. Can you please, does anybody else have the same issue? Can you please write it down? If it's the same, then it will be on my side. If it's not the same, then I think it's on your side, Paul. Thanks for your feedback. Can anybody please confirm or infirm what Pavel is saying, that my screen is not refreshed? Please, folks, I need feedback. Okay, that's bad. Okay, thanks. I will then try to stop screen sharing, and I will screen share again. Can you please, thanks a lot for your feedback. Can you please confirm that now you see my IDE? No, I share. I'm sure I share the screen and not the app. Is it good now? Are you seeing my IDE? IDE, woohoo! Thanks. So I hope now I will switch to the browser afterwards. So now I have. Thanks a lot for your feedback. I have loaded the static data. Now I will send the job to actually query the web service. So again, if we look at it, you can see that's exactly what I described. So we are reading from the service, then we are like splitting the payload, then we are mapping to JSON. I mean, it reads a bit like plain English. And here we filter entity, and then, well, and so on and so on. So now the stream has started, and we can see that there is. And now the next step is actually to start the web app. And then if everything works out as expected, if codes are with me, when the web app starts, it will register to the IMAP where I have my events. So normally, yes. And now I can go on my browser. Can you please tell me if you can see my browser? Otherwise, I will unshare and share again. Anybody can see my browser? It would be nice. No. Yes. I have. You are seeing my browser, and you can see that here that the boss is moving a bit. So it's not moving on the line because there is something missing from the demo. Thanks. There is something missing from the demo. Is actually I'm like, there is an interpolation, so it's goes from one stop to the other in a straight line instead of following this route so far. So if you want to do some coding and you are a front-end developer, because I'm not, then it's time for that. So it interpolates the path. I interpolate the speed, and then every time, because I don't on the front end, I don't like do it as fast as possible. Otherwise, I'm overflown with events. So I just stop the stuff. Meanwhile, it interpolates, and when it receives a new event, it puts it in the location of that the event told me. So you know that every now and then it interpolates, and then it puts it back in the correct position. So it's not perfect, but it's not that bad. And again, if you have ideas or skills regarding front end, I will be very happy if you like do some pull request on the stuff. And now it will be very to go back to Linus. Again, could you please tell me if you see Linus now or if it's still the browser? Okay, I will assume that you see Linus, then I will keep talking. Yes, I forgot about the lag. Let's see if it works. So I want to recap. Going from batch to streaming has a lot of benefits. Of course, there are issues. If you can use open data, then you can do very, very cool stuff that I tried to show you so far. And you can read my blog, you can follow me on Twitter, you can read more about Jet. If you're interested in the source codes, because I was very, very fast, you can get it here. Everything is on GitHub. And if I got you interested in Hazelcast, join our Slack or get some free training. So thanks a lot for your attention. I'm just on time, and I will check if there are some questions in the QA. I see no questions, so I don't know if it's a good or a bad stuff. Just let me know if you've got more, like some questions. We have 1 minute and 20 seconds. So I will be very happy to answer your question. If you don't have any question now, well, I will still bit on time, but then afterwards, just ping me on Twitter. My Twitter DMs are open. So I see no questions so far. Again, I forgot the lag. That's really, really bad. No questions. Okay. I thank you a lot for your attention. Thanks for your feedback that you didn't see the stuff. I really appreciate that. I hope next year I will be able to visit in person. And in the meantime, please stay safe. Have a good day and enjoy the rest of the conference.